a desire to be the first African American in space. My desire was to make a contribution, just to make a contribution. And I think I probably told people that I would probably prefer not being in that role versus being in that role, because I figured being the number 2 guy would be a lot more fun.
Up here trying to figure out what happens to the human body in zero G. We are the world. We are the children.
It feels like you weigh twice as much as you normally do during the entry portion. Once you get on final, all of the emotions and focus are just on that last little bit of landing, and it's a neat way to end a flight when you actually get to put your hands on the stick and fly it yourself.
Gear down and lock. Touchdown.
Engines throttling up. 3 engines now at 104%.
Challenger, go with throttle up. Challenger, go with throttle up.
We come together today to mourn the loss of 7 brave Americans, to share the grief that we all feel, and perhaps in that sharing to find the strength to bear our sorrow and the courage to look for the seeds of hope.
Risk is something that we have to just really consider as part of our life, especially in exploration. I know we've had some tragedies, and we'll probably have tragedies in the future, but you know, the ones that we've lost were probably the first ones to tell you, keep pressing on, don't stop because of us.
My role as a mechanical engineer was to find out, you know, what fell apart or what happened. And we finally found that the O-ring is supposed to be designed so that pressure on one side pushes them more securely into place. The housing for that big O-ring was just the opposite. The pressure actually pushed it out. Finally, of course, when the thing burned through and actually burned the nozzle through, it was pretty obvious to see what the problem. So with we got the job of redesigning.
1, 0, and liftoff. Americans return to space as Discovery clears the tower.
Roger roll, Discovery.
Good morning, Discovery, and you got a go for HST deploy arms.
NASA opened the decade of the 90s by placing the Hubble Space Telescope into orbit. It would peer farther into space and further back in time than any other telescope. And in the closing decade of the 20th century, Hubble and a host of other robotic explorers would provide astonishing new views and perspectives.
Everybody was up. We were off to discover the secrets of the universe. It was great. And then things started to be sort of scratch your head. Why is it taking so long? Why can't we focus the telescope? What's going on? What was wrong with Hubble is kind of the same thing that's wrong with your eyes when you need glasses. Basically, the shape of the lens was wrong. So in essence, the telescope was nearsighted and it needed some glasses. I was taking a shower in the hotel in Germany, and they have these really funny shower heads where the shower head will kind of move up and down and back and forth, and that's when it dawned on me. We can have this instrument robotically raise up the corrective lens, flip out, if you will, just like that shower head, these other corrective optics to correct the aberration for all the instruments. All of the work leading up to the first servicing mission is probably the most exciting time of my career.
The NASA program changed the nature of astronomy. We made some extravagant promises on Hubble. We undersold the program. Whatever we said, Hubble did better, I think. It really changed the nature of what we know.
Hubble is one of the most phenomenal things we've ever done in space. Data that we get from Hubble will continue to change the way we think about ourselves, about the universe, and our place in it. You know, the pictures from Hubble are iconic. You see them everywhere. The fingers of God. This is the gas pillars that are actually many, many, many light years across. So the scale of these things is enormous. And you're actually seeing the birth of stars. This is star nursery. It starts to give you a sense of how small we are and how vast the universe is. And that's my favorite picture.
NASA, especially Goddard, was the place where I could carry out the dreams that I had, which were to push forward an experiment that would measure the Big Bang radiation better than anyone had ever tried before, and took on the job of working on COBE. For many decades, people didn't agree with the Big Bang theory. They thought something else must be true. Generations of astronomers thought it must have been the steady-state theory. Einstein didn't like the idea. So when we got the measurements that fit exactly on the theoretical prediction for the Big Bang, this tremendous sigh of relief went through the world as well. Our measurement of the hot and cold spots in the Big Bang radiation, which show us not only is the Big Bang theory right, but also it gives us the map of the seeds of the structure, the things that will eventually grow into galaxies.
The Galileo probe, which sent its spacecraft into the atmosphere of Jupiter, was the most demanding entry probe ever flown by anyone, and it worked perfectly.
Europa and some of the other satellites where there seems to be accumulating evidence for water are getting to be very, very interesting places for exploring. I mean, who knows what's under the ice surface in Europa? You've got water. Looks like there's salt water. You wouldn't have water if you didn't have a source of energy. The odd coloration gives some hint of the presence of organics. When those conditions held on the early Earth, life developed in a couple of 100 million years. Well, maybe there's something interesting on Europa.
I tell you, there is nothing as beautiful as Chandra sailing off on its way to work.
Nowadays, we're discovering what is the universe really like, and it's totally magnificent. And one can only be inspired and awestruck by what we find. So I think a proper response is complete amazement and awe at the universe that we're in. And how it works is just far more complicated than humans will ever properly understand.
Houston, Atlantis, we have capture.
Mir was a successor to the early Salyut space stations that the Russians built back in the 70s.
Well, I was extremely fortunate that I was able to be part of the Shuttle Mir program. So obviously, there were a lot of challenges when you're trying to work with a different culture. I mean, it was a challenge for the Russians, it was a challenge for the Americans, but everybody wanted to work together to make it come to pass.
I definitely think it started teaching us the lessons we needed to learn, and it was key to that. Very technical things that, you know, seem simple but become very complicated just by language and cultural definitions of things that, you know, I think our guys did a phenomenal job bringing all those pieces together.
Booster ignition and liftoff of Discovery with a crew of 6 astronaut heroes and 1 American legend.
The flight I was on, Discovery in '98, we had 83 different research projects on that one flight. You go up for a couple of weeks, say, and you find some of the things occurring on the human body that are much the same as getting old right here on Earth. The body's immune system changes, you get less resistant to disease and infection. The body's ability to replace protein in the muscle becomes less. And so the question was, could we find